actually start our webinar for today. So just a few reminders about your notifications. So basically, as you can see on your screen, we would like to request everyone to please, for you to have a laser focus attention on this webinar, we would like to request to turn off those notifications from your end. So as you can, the instructions are on your screen right now. And of course, if you do have any questions, please post them in the Q&A function section of on the upper right hand of your screen. All right. Okay. I see. All right. Cool. Okay, so for those who are new here, I would like to introduce myself. My name is Marvin, one of the course advisors here at EIT. I'm actually based in the Philippines. So if we do have participants here from the Philippines, please send us a thumbs up, a heart, okay, a heart so that we can actually see you. And of course, for those, for other countries as well, welcome. Welcome to the webinar. Okay, so yep, for common questions and FAQs. So basically, this is the most common question. For those who, for everyone who actually registered to this one, will be able to receive a copy of the slides and video recordings for the next 2 business days. So just kindly monitor your junk mails as well because it usually goes straight there. And of course, since this is a technical topic webinar, we'll be providing this attendees until the end. Those who attended until the end of the presentation or the webinar, you'll be able to receive a certificate of attendance. But first, you need to fill out the survey form for you to be able to get your certificate of attendance for today. Okay, so just a little just give you an idea about EIT. So we are an engineering specialist. Okay, so we are an education provider based in Perth, Western Australia. We also have a campus in Melbourne and also just recently opened our Brisbane campus. So again, we specialize in engineering courses. We offer a wide range of programs, starting with our professional certificate course. We also have our diploma and advanced diploma courses, bachelor courses. We also have our graduate certificate and graduate diplomas. Also, we have masters, and of course, the highest one is Doctor of Engineering. Okay, so these programs are industry-oriented programs, which means that whatever you will learn here is based on the industry and what is really needed there. Okay, so the skills and knowledge that you'll be getting here is valuable to employers, so that you can, when you be in the field, you're ready. Okay, and then at the same time, our programs are accredited by the Australian government, and at the same time, some of our programs are accredited by engineering bodies such as Sydney, Dublin, and Engineering Accords, Sydney, Dublin, and Washington. All right, and these programs are actually delivered by industry experts themselves, like Dr. Amir here. Okay, and then these programs are being delivered by unique delivery methodology, like using our webinars, like such as this, and of course using our virtual and remote laboratories, which makes use of simulation and softwares. Okay, so without further ado, I will allow Dr. Damir here to introduce himself. So, Dr. Amir, the floor is yours.
Hi everyone, hope you're doing well and you have a good morning or afternoon. In Sydney, I'm in Sydney and it's afternoon, but I think most of you are from different part of the world. Good afternoon or good morning. And I'm a lecturer in EIT for last 4 years, and I'm doing the course related to the electrical engineering and engineer, network designer, network planner for about 18 years. And also I'm a senior lecturer here in EIT and other university. I'm teaching the courses related to the electrical grid and telecommunication. That's it. I think that's a short kind of
Thank you,
introduction.
Thank you, Dr. Amir.
No,
I just want to check with you. Would you be able to control the slides?
let me
Yeah,
sit. I will
the
take a
upper.
controls.
All right, amazing. Yep.
Yes.
All right, cool.
I think
Thank you so
I
much,
have
Dr.
the control of the slides.
Yep, you already have the control. Thank you, Dr. Amir.
Yes. And it's a bit small in my screen. I'm not sure how I should make it a bit
Yeah,
larger.
yeah, it's a bit small from your
Let
end,
me,
but from our audience today, it's the whole screen. So, yep.
Okay,
Okay, yeah, that's cool.
let
You
me
can do that.
see if, yes, let me see. Okay, let me see if I can read it. Is it any way I can increase a bit the size of this one because the layout, content control. Let me see how I can increase the size of this. No, it's not possible like this. Sorry, just a second. Recording. Okay, that's fine. I will start with this one. Okay, today we have a webinar about the data communication, the backbone of the modern power system. Why we need the data communication and why we call it as a backbone of the modern power system. We will go through the introduction of the data communication in power system. After that, we will review a couple of the communication protocols and standards. Then we will go through the optical communication technology in a power system, and then we will talk about the integration of the IoT and the advanced data analysis. Why we need the data communication for IoT or advanced data analysis. And after that, we will find the solution. And end of the future trend, what will happen in the future, and what is the most likely situation for us in the future. The first thing, why do we need a data communication network in a power system? The power system is a system that working with a generator, with a motor, with the consumptions, with the transmission line, with the distribution line. What is the relation between the power system and communication? The power system should just only rely on the power elements of the network, not to the communication, because the communication and power, it looks like from the behind when you look at these two parameters, you see, okay, it's a totally two different area of the work, but no, it's not correct. We need a communication for all the power system, for all the electrical grid. As you can see, in the electrical grid, we have three main parts. The first part is a generation station. The generation station looks like the power plant. They generate the powers. Next one is a transmission line. You generate some power in a power plant and you want to transmit the energy, the power, the electricity from the power plant, for example, 200 kilometer, 300 kilometer, or 100 kilometer far from the end user, and transfer the power there. How you can send this kind of energy through the network. And after that, when you use the transmission line, you will reach to the distribution. When you come to the city, you cannot have a transmission with a high voltage. You need to drop or step down the voltage and go with the substation transformer for the distribution. And why we need the telecommunication for this system. Everything is related to the power. As you can see here, the key component of each electrical network is a power generation section. The top side of this photo, as you can see, we have a wind farm, we have a solar farm, we have a battery storage system, we have a hydro power plant, or we have a gas or fossil fuel power plants. We generate some energy here. Then, in order to be able to send this energy to other part of the network in a different geographical area, we need to step up the voltage. If you want to send in a voltage and current that you generate the energy, you will have a high loss during this transmission line. You have a 200 kilometer, 300 kilometer distance between, for example, the generation and the consumption. If you want to send it with a low voltage and high current, most part of the energy will be wasted through the transmission line. In order to avoid those kind of issue, we step up the voltage. We increase the voltage. For example, we change the voltage to the 400 kilowatt with a low current, and we send it through the transmission line. Near the city, for example, you will receive the 400 kilowatt and you step down one step, for example, 230 kilowatts. From 230 kilowatt, you will go to the couple of the substation around the city, and you will step down to the 63, for example. In a different country, they have a different level of the voltage. You will have a transformer, you will have a substation, you will have a transmission line, which is a high voltage, 400 or 230 kilovolts. And after that, you will have a distribution. For example, in a distribution substation, you will step down one step more, and you will come to the 20 kilowatt or 63 kilovolts. Then you will go to the each area, for example, each different suburb in the city, and again, you will step up in a 20 kilovolts. After that, you will go near the end user, and from 20 kilovolts, you will drop it to the 220 volts, and you will deliver the voltage to the customer. As you can see, power generator, transformer, substation, transmission line, distribution line, and consumer connection point is a main part of these networks. Okay, in order to make sure this power generation and this power consumption are exactly similar to each other, the amount you generate is equal to amount of the you use, and the network and system is stable, we have a couple of things we need to do. We need to have frequency regulation. As you know, in a different part of the network, you have different level of the voltage. As we talked, we have, for example, 400 kilovolts, 230 kilowatts, 60 kilowatts. If we want to check the stability of the network based on the voltage, is not possible. Where you want to check the stability? If you want to check it based on the current, based on the end user, based on the device that you connect into the network, you have a different current. It's not possible to change the voltage and currents. The main things that it's fixed in from the generation to the last or end user is a frequency. The frequency should remain fixed. For example, here in Australia, the frequency of the network is at 50 hertz. From the transformer in a first part to the last section, everything is a 50. We need to make sure that this frequency will remain fixed all around the network. Also, we need to manage the frequency variation. We shouldn't let the frequency, for example, change more than 0.05%. If it's go more than that, our network will not be stable. We need, with this frequency control, also we can have a voltage control, maintain the consistent voltage level to support the grid performance. If your voltage has a fluctuation, for example, end user instead of the 220 receive 280 or 150, what will happen? What effect will have on the system? And it will affect the equipment safety. If you have a high voltage, for example, you're supposed to have a 220 volt to 230, it increased to 300, you will have a safety issue. And also, you need to make sure the voltage will remain in a stable condition in order to avoid the power disruption. We want to prevent the blackout or brownout of the networks. We will explain, okay, what is the blackout and what is the brownouts. After that, we need to have an efficient grid performance. We need to make sure, okay, our grid performance is efficient and everything is a specific range, enhancing overall stability and operational efficiency. And then we need to make sure our supply or the energy sources are reliable and it doesn't have any negative economic impact. Okay, we talk about the frequency and we said we control the frequency. How we control? If you have seen any dispatching or control center, you see always they have some things on some display in the front. It shows the frequency of the network every second and online. If the amount of the consumption is more than your generation, you can see your frequency will drops. As you can see here, your frequency will drops. For example, instead of the 50 hertz, it will drop to 49.9. If your consumption is exactly equal to your generation, your frequency will be fixed 50 hertz and your network is stable, you don't have any issue. If your generation is more than your consumption, you have higher generation and less consumption, you don't have any, you don't have enough consumer to use that power which is generated, your frequency will increase. If this increment, for example, your frequency dropped to 48, 47, or 51, 52, the network will be unstable and will lead to brownout or blackout of the network. Okay, what is the brownout or blackout of the network? The brownout is a partial voltage drop in the power supply. A partial voltage will be dropped in a power supply. For the blackout, the complete loss of the electrical power. All the network will be shut down. All the power plant will be shut down, and you will not have any energy or electricity in your network. The cause of the brownout is a high demand, grid instability, and intentional voltage reduction. But the cause of the blackout is a severe faults, system failure, or extremely weathers. If you have anything severe, will lead to the blackout of the network. Everything will be shut down. Also, the brownout is a temporary and can be from a minute to hours, and it's easier to solve it. But for the blackout, maybe it's short, but most of the time it will take us time. If your network is going to blackout, maybe it takes 1 day, 2 days, or 3 days even to return everything again in a stable condition. The effect of the on a device may work at a reduced efficiency. For example, if you have a light, the voltage drop, the light will be dimmer, or if you have a motor, the motor will not have a good performance. But in the blackout, you will have a complete shutdown. Sometimes the control of time, you can prevent by the overload, but for the blackout, usually unintentional and require restoration efforts. The impact of the brownout is less severe compared to the blackout, but the blackout, it will have a major disruption and issue. Okay, now we will come to the telecommunication and electrical grid. We know we have a generation, we have a transmission, and we have a distribution. We generate a power, we want to use it in an end user. Okay, how we want to make sure we have a balance between generation and consumption. Both of them are the same. We need some controlling system. This controlling system, maybe you use for sure you need to have a SCADA system, supervisory control and data acquisition, monitor and control the power generation, transmission, and distribution remotely. You can control, monitor the network remotely and make sure, okay, the level of the generation is equal to the level of the consumption, and all the device in the network will work perfectly. You have another control system, automatic generation control, AGC, adjust power output from generator to maintain the frequency balance. It will control automatically the amount of the generation to create this balance between the consumption and generation. Another device another system we're using is a wide area monitoring system, or WANS. They utilize phasor measurement unit, or PMUs, for a real-time grid stability monitoring. Real-time based on the phasor or PMU will control how stable is this network. Is it, for example, will increasing 1% or 2% of the load, it will be going to be unstable or not? Or if decrease the amount of generation with a 5%, 2%, 3%, does it make the network unstable or not? It will working on the stability of the system. And also energy management system, or EMS, optimize grid operation, load balancing, and power flow control. We have another system, distribution management system, which enhance real-time monitoring and automation of the distribution networks. All these one are the system which control the networks. We have a substation automation system. In the substation, you have lots of automation devices. You automate lots of process. You don't need, for example, if you want to increase the voltage or decrease the voltage, or increase the fan speed or decrease the temperature, whatever you want to do, you can automate it. With the automation system, it will be doing automatically, rather than you put an operator, manually change the parameter, change the value, and adjust it. Automatically with the control system will control everything. And we have a demand response management system, which is coordinate load reduction during the peak demand to stabilize the grid. If you're in a peak hours, for example, 6 or 7 p.m. at the night, that is a peak hours in your country. If you have some load that you can reduce the amount of the load to control the stability of the network, this system will come and start doing the load reduction. We have a smart metering infrastructure. You have a lots of metering or measurement device along your network, from the substation transmission line, inside the customer, inside the generation, or every step of the system. You need some metering or measurement, which is smart. It can be connected to the network or telecommunication system and send and receive the data. You have a fault detection, isolation, and restoration, which is FDIR. This system also is the automatic outage detection and restoration in a distribution networks. And also we have a microgrid control system. All of this system, they use some parameters, some sensors, some smart devices in order to control the network. Okay, you have some sensors, you have some smart device, you have a meter, you have automation system. How you want to connect everything together? What is the missing part of this one? Your sensor measuring the data. Can he do the automation exactly in the field? No, it's not possible. You need to send the data through a control center. Control center will receive this data and also will receive the data from different section of the networks. And based on that, it can make a decision. Okay, right now we need to increase the level of the voltage or decrease the level of the voltage, increase the generation, decrease the generation, or whatever you want to do. Okay, how you can send it? You need a telecommunication system. Here is the main role of the communication. For all this control and stabilizing part of the network, we need to have the telecommunication system. Without telecommunication system, we cannot control the network. As you can see here, we have a physical layers. In the physical layers, as you can see, energy flow is just in the red line. Here, you have energy flow, we have electricity between generator, transmission, distribution, and end user. From this physical layer to the network layer, which is the start of the telecommunication system, you need to have some communication link or interface. You need to connect your transformer, the sensor of the transformer or a smart device of the transformer to the uh, telecommunication system. You can use different telecommunication system. As you can see here, this is a optical fiber or satellite or mobile, for example, 4G or 5G, that they will receive the data from the field devices or physical layer, and they will transfer this device to the cyber layer. In the cyber layer, you will receive all the device. You will store the device. Maybe you have some cloud or some storage. You will store all the data that you receive, and you organize the data. You will put, for example, the data from the metering in a specific section. You will put the data of the RTO in another section or different part of the net, the storage or cloud. After that, in the top layer, you have the application layer. You have the market. Market need to have access to some part of this data. Operation, control center need to have access to this data. Service provider, they need to have access to a part of this data. We will give access to every specific part of this data to a specific user. For example, for a market, we will just give the metering reading. For the operation, we will give the control data, how they can control, how they can increase or decrease, or the fault detection. For the service provider, we provide a specific access for that data. This is the role of the communication. This is this part of the network which we use. If we don't have this one, we cannot transfer the data. We cannot receive any data, or we cannot control the data. Because of this, it's important that you have a data communication. Okay, for data communication, we have two main or major categories. One of them is a wired communication. The second one is a wireless communication. Okay, in the network for the wire, we have a fiber optic network, which is a high speed with a low latency communication for substation, SCADA, and backbone of the networks. We use a fiber optic in order to transfer a high amount of the data with a high security and low latency. The next one is a power line communication or PLC, which use existing power line to transmit the data for a smart grid and remote monitoring. The next one is the external IP network, which is a reliable high-speed communication for the substation, automation, and control system. For the Ethernet, you can use it locally. Usually for the Ethernet, you don't use the Ethernet or Internet or the shared communication system if you want to send the data out of the network, out of the area. For example, you are in a substation. Inside the substation, you create a networks and connect everything to that network, and you can send and receive the data. But if you want to connect your networks, for example, your substation to control center, which is a 300, 400, 500 kilometer far from the substation, do you use the share data? Can you, for example, say, okay, I will buy a internet connection and transfer everything through the internet? Is it safe? No, it's not safe. Also, is the speed of the transmission is all right for this important application? No, it's not. Is the latency is all right? Can you use it, for example, for your protection system? No, it's not. Another things we have a SDH network. SDH network will receive the data from different part of the network. They will pack it in a different pack, for example, STM4, STM16, STM64, or even DWDM. You send all the packet from the substation to the control center or opposite side. You have MPLS, you have a leased line, for example, is a private or secure line for a critical and grid communication. You can have a coaxial cable network, which is kind of old, and with a new technology and new system, we don't use that much the coaxial cable or even RS-232 or RS-485, which is a legacy system, and we are not using that one. Beside this wire communication, we have wireless communication as well. For the wireless communication, we have a microwave communication, which is used for high-speed data transmission over a long distance. For example, you want to send information from one substation, which is a 80 kilometer, 70 kilometer far from the city, and you don't have any communication line, any fiber. You can use a microwave. Or you want to use a cellular network, 4G, 5G, or any other cellular network. You can use for the remote metering and grid management. But again, this is not that stable. If you having big network, you don't want to risk and just for one single link or one share area with the public, you lose your data. You have a satellite communication. If you have a remote area and you don't have any access, you can use a satellite. You have a Wi-Fi, which you can use for the local monitoring and control. For example, inside the substation, you can use a Wi-Fi and connect your smart device to the Wi-Fi, send and receive the control. But if your distance is a line, if it's a 1 kilometer, 2 kilometer, 3 kilometer, then the Wi-Fi is not working. You can see based on the distance, based on the amount of the data you want to send, how many kilobit or kilobyte or megabyte you want to send per second, do you want to send and receive, or how is the data transmission settings. You can select one of these transmission system. You can have a low LoRa WAN, which is a long range wide area network which support the low power and long range communication. Or you can have a Zigbee, which is used for the smart meter and home automation. You can have a Bluetooth for the short range device communication. For example, you want to measure temperature of the transformer in different parts of the transformer. You have a 5 sensor, 6 sensor. You can use a Bluetooth and send everything to a modem near to that transformer, and this modem will send this data to the control room. Or you can have a Wi-SUN, which is a wireless smart utility network, which is designed for the smart grid applications. As you can see here, here is your physical layer. You have generation, transmission, distribution, and customer. Here, it will be the main loop that we are talking about, is your network layer. Is a backbone communication network, wireless communication, distribution communication networks, or wired communication. It will connect this side to the next or upper side of the network. If you don't have this one, if you don't have the communication system, you cannot gather the data, you cannot control your generator, you cannot control your transformer, you cannot automate your process, and you cannot give access to the application or end user to use the data. Because of this, we are saying the communication is a backbone of the power system or electrical grid. Why should we utilize optical fiber as the backbone of the electrical grid? Why not 4G, 5G, Wi-Fi, or other kind of telecommunication system? As you can see in this photo, we have a satellite communication in a part of the network. We have a AMI in this part of the network. We have a wireless communication here. We have some PLC and fiber here. In different part of the network, we have a different sort of the communication. But when you want to add everything together and send it to the main control center, as you know, every electrical grid has a main control center. For example, in the city, you have a main control center and it's connected to all area of the country. All the data should be gathered together with a switch and send it through the main networks. Why we need an optical fiber for this one? The backbone here is the backbone of the network. As you can see, we gather all the data from different telecommunication systems, from the Wi-Fi, wireless, satellite, PLC, or any other communication system, and send it through the backbone in order to connect it with the control center. Why we say the optical fiber? Because it's immunity to the electromagnetic interference. Electromagnetic field, it doesn't have any effect. Inside the optical fiber, we transfer the laser or light. Electrical magnetic field doesn't have any effect. But if you have any coaxial cable or any RS-232 or 485 or any other cable, the electricity or the field of the electricity will affect on that one. But in the fiber, it doesn't have those kind of effect. In addition to this one, the optical fiber has a high speed and it can go with a long distance. For example, with a copper cable, you cannot go to the long distance. With a microwave, you need lots of repeaters. For example, you need to have a line of sight. You need to see from this antenna to the next antenna, you need to have a line of sight. You can see the next antenna in order to be able to send the data. It's costly and the quality is not good, and it's related to the weather condition. If you have a bad weather condition, the quality of the communication will drop, and it will not work for the important networks such as the electrical grid. Optical fiber support high bandwidths and low latency, essential for real-time grid monitoring and automation, can transmit data over 100 kilometers without significant signal loss. You can send 300, 400 kilometers, whatever data you have. If you have a 10 gig, 100 gig, also easily you can send it for a long distance. It's ultra reliable communication for a protection system. One of the main things we have in the network is a protection system. The protection system, if there is any fault in the transmission line, in a transformer, or any part of the network, this protection will solve those issues, will face those kind of issues. And they need a low latency. If you have a high latency, it doesn't have enough time to trip and disconnect the line. And it will lead to brownout or blackout of the networks, availability of the optical power ground fiber. You will have an OPGW. Instead of the ground wire on top of the transmission line, you can use an OPGW. It's a kind of cable. At the center of the cable, you pass some optical fiber. It's safe, it doesn't have that much cost, and it can have all benefit of the optical fiber. It will enhance the security and reliability. The main point in electrical grid is the security and reliability of the grid. And also, it's good for a smart grid and SCADA integration, and it had a low maintenance and high lifespan. As you can see here, we have a band, we have a hand, we have a IAN, and we have a different network, Wi-Fi or wireless or whatever we have. We gather all the data, we give it to the backbone, the backbone will gather all the data all around the country. For example, you can create a one main ring and one backup ring and connect everything to this backbone. And this backbone will connect you to the control center, main control center or cloud or wherever you want to store your data. Rather than optical fiber, 4G, 5G satellite is not able to do it because of the quality, because of the safety and other parameters. The only system that can have everything together is optical fiber. The application of the optical fiber in the grid is stochastic and grid monitoring and control, as we already talked. We can use it for substation automation. We can use for the teleprotection and relaying. You can use it for a smart grid and wide area management system. It's energy management and this demand response. You can use it for a high-speed communication. You can use it for a smart grid integration. You can use it for the security and surveillance. You can use it for the distributed energy resource management, or you can use it for the temperature and strain sensing. You can use for all this application. Before fiber, we didn't have that complex network. We didn't have that much data gathering, and we didn't have that much automation, and everything almost was doing locally or doing by the PLC or microwave. But after the fiber and the new generation of the system installed in the power plant, in the substation, everything changed. And the amount of the data we generating increased. We have integration of the IoT and advanced data analytic. As you can see, in the new generation of the device, every device is a smart device. You can connect this device to the internet and control it wherever you have. For example, you have the alarm in your house. They said, okay, you can connect this alarm or this camera, your house camera, to the internet and control from wherever you want. You can open this section from the overseas. You can control this section from the overseas. Everything is based on the IoT and data analytics application of the IoT. In the electrical grid also, everything changed after the invention of the new technology and IoT. We have a smart grid monitoring, which is a real-time tracking of the voltage, current, and grid health. We have a fault detection and predictive maintenance, which we use from, we get help from the IoT. We can have a demand response management, adjust the power distribution based on the real-time demands. We can have a renewable energy optimization, balance the solar and wind energy integration into the grid. We can have an energy theft detection. We can have a grid automation and self-healing networks, and we can have a cyber security and instruction detection. Everything's coming with the IoT, with the use of the IoT. Okay, we have an IoT, we have a different system, but every system will generate some kind of data. For example, here you have a distribution management, you have a running state of the equipment, you have a dispatching automation, you have an equipment parameter, you have a load control, and you have a marketing system. This data is a structured data. They have a specific structure. Some of the data is not is a semi-structured data. For example, web service data is a semi-structured data. You have some other data which is unstructured data. For example, customer service or metrology information. It's unstructured data. You will gather lots of the data based on the IoT. Some of them is a structure, some of them is unstructured or semi-structured. No, you need to send it or you need to receive it. You send this data through the control center. Control center will check the data. Okay, right now I need to change this parameter in the field, which is 100 kilometer, 200 kilometer far. How I can do it? This IoT, without communication, they cannot do anything. The smart device are based on their communication technology and system. If they don't have a communication, they cannot do anything. For example, before and after, we have a before and after data, before and after IoT, we have a limit data collection and manual data collection. But after the IoT, we have a continuous and real-time data communication collection for the monitoring, for the data processing, for the fault detection, response time, grid control, energy management, and network stability. This IoT change the scenarios, make everything more easy, straightforward, and we have a higher control over the network and the system that we have. We have better customer interaction, we have better security, we have a higher cost efficiency, we have a better grid resilience, we have optimization, maintenance, customer interaction, and security. Based on this information, based on the information we receive from the IoT, we improve the performance of our network. Okay, can we have an IoT and data analytic without telecommunication backbone? What do you think? No, it's not possible. IoT device need connectivity. Your smart device, if you cannot connect it to the internet, it cannot do anything. Here also, if you cannot connect your smart device to the communication system, it will not do anything. Data analytics require large-scale data transfer. You need to gather lots of the data from the substation and process those data. Without communication, you cannot do it. Grid automation relies on an instant communication. Security and monitoring depends on the network infrastructure. Everything is related to the communication system. The telecommunication system is the backbone of the modern smart grid, enabling real-time communication, automation, and control. You can control your network wherever you are in the world. You can have a remote access or VPN access to your network and control the network. With integration of the IoT and data analytics, the role of telecommunication has become even more critical in improving the performance, efficiency, reliability, scalability, and cost reduction of the electrical grids. As you can see, here is the challenge and the solution for the telecommunication system as the backbone. You add lots of smart devices to your network. You add lots of sensors, lots of metering devices. You need to gather all the data. You need to transfer all the data. Network reliability and latency, it's an important factor for the IoT. Power grid required ultra reliable and low latency communication. The solution for this one is deploying the 5G, fiber optic, and edge computing to ensure real-time data transmission. You have a cyber security and risk. Power grid are vulnerable to the cyber attack and data breaches. Implementation, encryption, firewall, AI-based threat detection, and blockchain security. You have scalability of the infrastructure, expanding communication network to cover larger grid is a challenge. You can use the LPWAN and cloud computing and decentralized edge network for the scalability. You have interoperability issue. Different device and protocol cause integration problem. You can adopt some protocols, communication protocols like IEC 6185 or MQ2T or DMP3 for seamless connectivity. You will have an issue with the regulatory compliance. Power and telecom industry face strict regulation, ensure compliance with the global and national standards while adopting the new technology. If you want to add anything new, you need to make sure, okay, it will follow all the standards and all the protocols we have. Data overload and processing. Massive IoT require advanced analytic and storage. You gather lots of data from different parts of the networks. And also, you have a harsh environment control, you have a power supply and telecom equipment, and you have a regulatory compliance. The future trend for this system is using the 5G environment. For example, use a 5G or 6G network. They are ultra low latency and high speed communication for real-time grid operation. But the issue with the 5G and 6G and wireless is the safety and security issue. You don't want to share your data and other also can have access or can get the control of your networks. You can have an AI-driven network management in a future trend. You can use a AI in order to control your network, help of the AI. Right now, you have some automation, but you have some operator that they make an important decision. You can train the AI and use that one. You can use edge computing, which is faster data processing at the grid nodes and reduce the latency to enhance the quality. You can use a quantum communication, which is a high security data transmission to protects against the cyber attack. Also, you can have a blockchain and grid security. You can have a software defined network or SDN, or you can have a digital twin technology. With this kind of technology, with this kind of parameter, in future, you will need to change lots of things in your network. It will change most part of the network. As you can see with the AI, everything's in our personal life also it will change. Up to 3 years ago, 4 years ago, if someone tell you, okay, we can use a chat GPT to do this kind of activity right now, we will do, no one will accept it. So no, it's not possible. But right now, everyone using in their daily life. For the telecommunication, also we need to look forward and deploy new technology and system in order to improve the performance of our network. Thank you very much, and we are open for a question.
All right, thank you so much, Dr. Amir. So, yeah, for those questions, what courses are covered by this topic? So, basically, we do have. Let me just take control of the slides, Dr. Amir.
Yes, sure.
All right, cool. So, what courses are covered by this topic? So, we do have these courses on your screens right now. We have the Graduate Certificate of Internet of Things for Engineering Foundations. We also have the Professional Certificate course of 5G Technology and Services. We also have the Advanced Diploma of Industrial Data Communication, Networking, and IT, Professional Certificate course in Industrial Data Communication, Professional Certificate course in Industrial Internet of Things, online Bachelor of Science in Electrical Engineering, and also Advanced Diploma of Applied Electrical Engineering courses. So if you do have any inquiries about the course, please feel free to reach us, or any of these courses, please feel free to reach us here at EIT, and of course, we'd be happy to assist you. Okay, so yep. For the future webinars, okay, so as you can see on your screens, we do have webinars this coming March. There are 3 of them, okay, that's on your screen. And then Yep. So now we are now proceeding to the Q&A section. So we will allow our audience to ask questions directly to, you can post your questions on the Q&A section so that our presenter today will be able to answer those questions. So we do have one here, Doctor, which is coming from Shisa. What about electronics and communication engineering, IoT and AI, which has more future advantage? Dr. Amir?
The IoT and AI is kind of connected with each other. Right now, we have a IoT. The AI is a bit newer technology, but I think both of them is a part of each other. You cannot, the IoT will be separate from the AI. Both of them, they are connected and we cannot separate them. Both of them in engineering, in electrical engineering and telecommunication will play an important role. We cannot say, okay, IoT is more important compared to the AI. Both of them, they have the same importance. And the future will be based on the IoT systems and AI control systems.
You, Dr. Amir. And here's a follow-up from Shiza. How about blockchain? How can blockchain technology improve data security and reliability in energy communication networks?
The the blockchain, I'm not a professional in a blockchain, but with the blockchain, with the dividing in a different section, I think it's easier to improve the data security. You don't need to send all the data in a with a long distance. I'm not quite professional in a blockchain,
Yep.
but I think the main concept of that one is processing the data in a decentralized area in a different part of the networks rather than sending and gathering all the information in the same location.
All right. Thank you, Dr. Amir. So, Shiza, I hope
Okay.
it answers your question. Yep. So, yep, can we have another question, guys, from the team, from the audience today? We still have a few minutes. Another one from Nielsen, Dr. Amir. How do we harness data from the power transmission line? Good
How
question.
do we harness the data from the power transmission line? The power transmission line, we have a different control system. We gather the data, we have a different parameter we check in a transmission line. For example, we check the level of the voltage, the current, the vibration, the speed of the wind, or different parameter. We can gather everything with some system is dependent on the location of the power line, and we can transfer all the data to the one of the transmission substation or distribution substation and gather all the data, we pack it with other data from the substation and send it to the control center, or send it through the automation system inside the transmission substation.
I see. Thank you, Doc. And we have another question from Shiza. How can developing countries enhance their power system data communication infrastructure cost effectively?
This is the cost effectively is the it's not an easy job to do it. For example, for the data communication, if you want to improve and enhance the system, you need to develop the new system. For example, in most of the country, they use the OPGW. The OPGW is optical power ground wire. If you want to haul a fiber from the ground, it will cost a lot. And with a natural disaster or from the flood or earthquake or anything, they will cut the fiber and your network will be disconnected. But the amount of the effect of the natural disaster on the optical power ground wire is much lower than the normal cable that we haul through the conjugate or through the ground. They can invest on the installation of the optical power ground wire, or this kind of system, install the new technology for the switches for the NGSTH, next generation of the STH, or DWDM, install this telecommunication system in their control center inside their substation in order to provide a backbone, in order to provide a network that will gather all the data and transmit it. If you have this one, if you have this backbone, you can connect everything inside the substation or transmission line or generation station to this backbone and transmit it. It likes a highway. You create a highway right now from wherever you want to go, you can use this highway easily. You invest here after 5 years, 6 years, 10 years, it will be full of the traffic that right now also we're going through the IoT and smart devices. You need this kind of backbone for your communication.
All right, thank you, Doc. We have another question from Tolulupi. The distribution network is so robust and challenging. How best can we handle data collection in the face of these challenges?
The data collection is depends. I know that the distribution always compared to the transmission, because the number of the substation increase, the area that you have this distribution substation is totally different with the transmission and is more difficult. Sometimes you have easier access to the public network or private network. For example, you have communication company, your country, you can lease the fiber from those communication, not a share fiber. You can use a private or dedicated fiber, use those system in order to gather the data. You can use some kind of wireless system if your data is not for your protection or is not important data to transmit through the city. But the for the most important and critical data is using the optical fiber to connect all the substation together and create a networks which is able to transmit or receive the data, and also using other network provider. For example, here in Australia, Ausgrid can use some fiber from Telstra in order to connect some of their substation inside the city, because it's difficult to haul a fiber, install or connect the substation together. But the telecommunication company already they have some fiber and easily they can connect the substation to the networks.
Thank you, Dr. Amir. So we have last four questions here. Probably will I'll just answer two, and then we will get back to the attendee for to answer their question via email. So let's have the last two here. Um, okay, so how will Ripple technology be affected by integration of IoT for load control within the distribution grid?
Let me see.
That's
Sorry.
yeah, because I can
Which
see
question?
questions. Yep, questions are coming in. So let's just have the last
Which
let's yep
how Ripple technology by affected how will Ripple
integration
technology be integration of the
integration
IoT of the load control within a distribution?
distribution grid.
How will Ripple technology be affected by integration of the? What do you mean by the Ripple technology? Can you give me,
Hmm.
because I'm not familiar with the Ripple technology. What is the Ripple technology?
Yep.
Integration of the IoT for a load control with a distribution
Hmm.
grid. The IoT, we always use a IoT or a smart devices in order to control the load in the distribution.
Hmm.
But for the Ripple technology, I'm not sure how it will affect the
Yep. So, Crystal, if you can
system.
actually
So,
send us some info about the Ripple
yes,
technology, and then we
it's
would
not
be
clear
happy to
for me
get
what is the Ripple
yeah
technology. Sorry.
get back to you on that one. All right. So, one
Yeah,
last question before we actually wrap up. What
yeah.
measures are in place to prevent data loss or corruption in power system communication networks?
We always in a power system communication network, we need to have some redundancy. Always, for example, you create different kind of protection system in a important section of the network. Always we have everything's redundant. For example, in order to make sure that our control center is safe, always they created two control center A or control center B in a different geographical area. If you have a flood, if you have an earthquake, or if you have any natural disaster or any attack to the main control center, the second control center, they can act as a main control center. We send the data through two different geographical area, which is in a separate location, and we have everything's protected and redundant. With this redundancy, we make sure, okay, if a part of the network we have an issue, we have a problem, another part of the network, the protection system will come to the effect and it will work and start to solving those issues, and we will not lose our data. For every server we can duplicate the server, have a protection server, and save it in a different geographical location. For example, one of your server located in a data center in the Melbourne, another one located in a data center in a Sydney. Then you can make sure, okay, these two servers are synchronized and you have all the data in these two locations and you can access from your control center. Yes, that's it.
Okay. All right. Thank you so much, Dr. Amir. So, yep, I think that's it for today. Thank you so much, everyone, for attending. So, for your questions about the certificate of attendance, here it is. So, kindly screenshot the QR code, and or I'll be posting it here, the link where you can actually do the survey, and then you'll be able to get your certificate of attendance for this webinar. Okay, so thank you so much, Dr. Amir. Thank you so much,
Thank
everyone,
you. Thank you very much.
for
Thank you,
attending,
everyone.
and I hope to see you in our future webinars. Okay, thank you so much, everyone, and have a good day. See ya.
Thank you. Have a good day. See you. Bye bye.